Thanks to lignite coal, North Dakota has the ability to power our homes, our schools, our businesses, our phones, our games, our laptops, everything. All from something mined from the ground beneath us. But with all those benefits comes the responsibility to use these resources wisely. For leaders in the lignite industry, that means continually looking at ways to improve how we do things, to make processes more efficient, with great attention to environmental responsibility. From the planning phases to the moment electricity is generated, mine and power plant operators take steps to be great stewards of our environment and provide environmental control. This is a phrase you'll hear a lot: environmental control. This refers to the steps that are taken to protect and preserve the environment. Let's take a look at some ways they do that. Let's start by looking at the power production process. All fuels, including gasoline, diesel fuel, natural gas, and coal, have byproducts resulting from the combustion process. Lignite coal combustion results in certain emissions that are necessary for the power plant operator to control, including, primarily, sulfur dioxide, mercury, nitrogen oxides, and particulate matter. Let's look at how each of these are removed to protect the environment. Electrostatic precipitators and baghouses are two ways particulate matter is removed from coal combustion gases. In an electrostatic precipitator, dust-laden flue gas passes through a chamber that imparts an electrical charge on particles, which causes them to be attracted to long vertical metal plates. The plates are then wrapped as necessary, causing the captured particulates to slide off into a collection hopper for disposal. Each of these devices has their own advantages for operating, but both of these methods remove particulates at a very high efficiency, 99.9+%. The resulting flue gas meets all emission limits for particulates and is protective of the environment. During production of lignite, carbon dioxide is also produced. With growing interest in managing carbon dioxide, power plants created a process to capture it. We'll talk about a specific example of that later. In the power production process, the flue gas, a gas that's created from the combustion process, is sent to a scrubber which cools the gas and cleans it by removing impurities. Then, the gas is sent to the CO2 absorber, where it meets an amine-based liquid. Amines are like magnets to carbon dioxide. They're used to separate or pull carbon dioxide from gases to remove it. Amines bond to carbon dioxide and pull it from the flue gas. This essentially turns the carbon dioxide from a gaseous state into a liquid state. This liquid is then transported to a regeneration unit where heat is added to break the bond between the amine and the CO2. The amine gets reused again, and the CO2 is compressed to a high pressure, which converts it from a gas to a liquid. From there, it can be injected to deep geologic storage or reused as a solvent to revive oil wells that are no longer producing. Innovations in the control of carbon dioxide continue to be made by the industry. One example of that is Project Tundra, a Minn Kota Power Cooperative initiative. Project Tundra would be the world's largest carbon capture facility installed on a coal plant. As this technology is demonstrated more and more, it could be something applied around the world to manage carbon. Water is an important component of plant operation that requires close management to minimize environmental impacts. Water is used for many purposes in the generation of electricity, including cooling, and in treating river or lake water to create the ultra-pure water necessary for steam production in power plant boilers. Any water discharged from facilities must meet the requirements of permits from regulatory authorities, like the North Dakota Department of Environmental Quality. It is the usual practice for plants to reuse as much water as possible. This conserves the water resource and minimizes the need to treat large quantities of water prior to discharge. Fun fact: did you know that's not smoke you're seeing from the chimneys at a coal-fired power plant? What looks like smoke is actually 99% water vapor. The water vapor comes from water inside the lignite itself, as well as the SO2 scrubbing process, which saturates the hot flue gas with respect to moisture. As the gas exits the chimney, it cools and condenses, creating a cloud of water vapor. The plume is hot air and can only be seen when the air temperature is cooler than the water vapor coming out of the stack and disappears as the air temperature warms up. Environmental control and stewardship is part of power production. Let's take a look at a few of our plants in North Dakota that give examples of how to do that. All power plants have requirements to manage emissions that are associated with the lignite fuel that is burned. Because there is sulfur in coal, it must be managed when coal is combusted. At Coal Creek Station, North Dakota's largest power plant, scrubbers are used for desulfurization. When originally built, the desulfurization system could scrub, another word for removing sulfur dioxide, 60% of the unit's flue gas. With enhancements and improvements over time, it can now remove more than 90% of the sulfur dioxide. Speaking of mercury emissions, mercury is a trace element in North Dakota lignite coal, and up until 2015 was not regulated by the Environmental Protection Agency. Since then, mercury emissions are regulated on all coal plants. To meet this requirement, the owners of the Coyote Station invested $2.5 million on a system that is highly effective at capturing mercury. The system employs two components. First, a small dose of halogen is burned with the lignite, converting the mercury to an oxidized state. That makes the mercury easy to capture by injecting activated carbon into the flue gas as it exits the boiler. The mercury adheres to the very small activated carbon particles, which are then captured as particulate matter in the baghouse. Similar technology is employed at all power plants in the state. Each year, Coyote Station spends $800,000 on activated carbon, and now mercury emissions are lower than the EPA standard. Fun fact: North Dakota has always been in compliance with the National Ambient Air Quality Standards, or NAAQS. Originally, we were one of only 6 states to be in compliance, even back in 1970, when the original Clean Air Act was passed. Presently, there are 15 states meeting all NAAQS, including North Dakota. In many cases, technology had to be invented to provide reductions in emissions required by the Clean Air Act. The power plants and research institutions have been very innovative in developing technology for North Dakota plants that have been used around the world. Leaders in the lignite industry are constantly looking at new ways to develop and innovate. As mentioned earlier, one of those developments is called Project Tundra, a project led by Minn Kota Power Cooperative and the University of North Dakota, EERC, with the goals of building the world's largest carbon capture facility right here in North Dakota. Research is continuing to create and apply technologies that would capture up to 90% of the carbon dioxide emissions from the generating units at the Milton R. Young Station near Center, North Dakota. To show just how much carbon dioxide that is, that would be like taking 800,000 gasoline-fueled vehicles off the road permanently. That's crazy. This project would also make North Dakota a world leader in developing next-generation energy technologies and home to the largest carbon capture facility in the world. We've just touched on a few ways the people in the lignite industry in North Dakota ensure environmental control. But it doesn't stop there. Even after the lignite is mined, sent through production, and turned into electricity, steps are taken to ensure the environment is protected and preserved, even more through land stewardship. After mining companies remove lignite from the ground, their next goal is to reclaim the land they mined. That means they return it to a condition that's as good or better than the condition they found it. Lands can be returned to 3 main types: hayland, cropland, or native grassland. If the topography and nearby resources support it, mining companies can restore the land into whatever type the landowner chooses. There are many ways to reclaim land, and leaders in the mining industry never stop innovating better ways of reclamation. Recently, the North Dakota Public Service Commission recognized 4 active lignite mines for their work on a research project to improve reclamation in our state. 2 examples of innovative reclamation really stand out: Harmony Lake and Coal Lake. Both started out as mined lands. But with dedicated, thoughtful work from mining companies partnering with North Dakota Game and Fish Department, these mined lands were reclaimed and turned into beautiful lakes that support a wide variety of North Dakota's native plants and wildlife. Coal Lake used to be a 120-foot deep pit. Now look at it. It's now a beautiful landscape with hills and a lake. Harmony Lake, near Hazen, was once a coal mine, but has now been reclaimed for recreational activities instead of being returned for agriculture. Innovation is always at the top of the minds of our agriculture and energy leaders. When faced with a challenge, they look at all the creative ways to address and overcome it. BNI was once faced with an issue of extremely hard soil that was difficult to work with. Creatively, they thought of the award-winning idea to use radishes, plants that are known for their deep roots, to break up the hard soil and provide nutrients to it. Another great success story of innovation comes from the Coal Creek Station near Underwood. Coal Creek produced 500,000 tons of fly ash each year through their lignite production process. Not wanting it to go to waste, they looked at nearby companies in North Dakota and surrounding states that use fly ash as a component in Portland cement to make the cement stronger and reduce the cement production costs. Each ton of fly ash eliminates a ton of carbon dioxide because making Portland cement is extremely energy intensive. Therefore, by using the fly ash left over from Coal Creek, producing Portland cement becomes much more cost-effective and efficient. Chances are you've stepped foot on this cement yourself. It is used in nearly all concrete poured in North Dakota, but was also used to create the new I-35W bridge, the U.S. Bank Stadium, and the Target Field in Minneapolis, Minnesota. You've just learned about a few ways North Dakota energy leaders preserve and protect the beautiful environment. Here's how that's paying off. Since 1970, coal consumed for electricity in the U.S. has increased by 111%. However, with the hard work of dedicated individuals in the lignite industries, in the last 40 years, there has been a 96% reduction in sulfur dioxide, an 82% reduction in nitrogen oxides, and a 92% reduction in particulates. Even just from 2007 to 2016, nitrogen oxides, an emission created when nitrogen and oxygen in the air are combined in high-temperature combustion, have been reduced by 46%, or 32,000 tons of it. Sulfur dioxide has been reduced by 67%. That's more than 90,000 tons. Mines and power plants are so dedicated to environmental friendliness projects that they've invested $2 billion into environmental stewardship technologies and spent about $100 million each year to operate this equipment and reclaim mined land. People that work in our lignite mines and power plants are North Dakotans after all. They care about this land just as much as anyone else does. They hunt, fish, camp, hike, all in this beautiful landscape we have in our state. And just like us, that beauty is something they want to keep around for many years to come.